that I want you to find an equation of a line, there's a formula that you got to know. Okay, and you need to write the formula down. You need to make sure you know it. I don't give this formula, so that thing we learned is the point slope formula. Remember how that goes? Y minus y1 equals what? M times x minus x1. Okay, like that. And basically that equation tells you how to do this problem. It really does. So what I'm doing is I'm giving you a point. So I'm giving you an x value. That x value is -8. Then I'm giving you a y value. That y value is 1, so that plugs in right there. Okay. So the thing is, well, you got to know the slope. Well, I didn't give you a slope, but I gave you an equation that could be graphed, and I could find the slope. Right? So if I give you an equation like in standard form of a line, how do you find its slope? You solve it for y, exactly. You want to go ahead and solve that for y and put that in the slope-intercept form. Okay? So you're basically just taking that form and isolating the y. Okay? You can move the x. You can just kind of do this in your head if you want to. So that's going to be 3y equals 8x plus 67, like that. Okay? Then what we're going to do is we can divide by 3, like this. So we get y is equal to 8/3 times x plus 67 over 3. Okay? So we solved it for y. So what's the slope? 8/3. Okay? It doesn't matter that 67/3 doesn't have any bearing on this problem whatsoever. What you're doing is you're finding the slope, see? Okay? All right, now I'm saying parallel line. I want a line to be parallel. If you have two parallel lines, what's the deal with the slopes? They're the same. Okay, so that means what you're going to do is you're going to plug in 8/3 in there. Okay, now what if I said just, because I could do this too, what if I said perpendicular? You would not use 8/3. What would you use if they were perpendicular? What we call the negative reciprocal. So, just study that, because I could ask either perpendicular or parallel. It's all kind of the same idea. So now what you're going to do is we're going to do y minus 1, like we have, equals the same slope, 8/3, times x minus -8, like that. So you're going to basically put this problem in the slope-intercept form. So we're going to go ahead and solve this. Okay, so we're going to get y minus 1 equals 8/3 times x plus 8, like that. Okay, so I've got everything put in here. And what we need to do from here, this is a place where a lot of times students go about doing this the wrong way. So when you solve this equation, what should I do to both sides right now? Multiply by 3. Get rid of the fraction, okay? You don't really need to do a distributive property. If you just multiply this side by 3 and this whole side by 3, then you don't have to worry about the fractions anymore. So that's the best way, in my opinion, to handle the problem from there, okay? So what you're going to have is 3y minus 3, okay? And then on this side, see the 3's cross out. So now you're going to be left with 8 times x plus 8, like that. Okay, then it's just a matter of multiplying everything out now and then solving. So, okay, so let me just move this kind of over here now. So we've got 3y minus 3 is equal to 8x plus 64. Okay, then get y by itself. So now you can add 3 to both sides. Like this. That's going to give 3y equals 8x plus 67. Okay, then you divide by 3, and then you'll be done with the problem. Okay, you don't need any, just make sure the fractions are reduced. So you're going to have y equals 8/3 x plus 67 over 3, like that. Okay, so the things that you want to be sure that you study from this is make sure, number one, that you know the formula. Okay, you got to know that. And if I say find an equation of a line, that's ultimately what's going to get you the answer. Yeah.
Can they be parallel if they're the same line?
Not if they're the same line. Okay. And what we've done is we've got a different line. So like if you look at the line, if you look at this thing right here, this is the line I gave you right there, okay? So what's happening on this is I've ended up with this. I guess it did turn out to be the same line, didn't it? That's kind of weird. It doesn't have to. Generally it doesn't, but still you consider them to be parallel, okay? Because again, what I've done is I found the slope, then I plugged in the point -8,1. You know, actually what that means is that this point is really on the line anyway. That's a good observation. Okay, he's just saying, look, the answer turned out to be the same as the original problem. They're still parallel. The reason is because that point -8,1 happens to be on the line. Okay, that's weird, but that's the way it worked out. So excellent observation. Okay, so be sure you study your formula. And what's the deal? Parallel lines have the same slope, right? What do perpendicular lines have?
Opposite.
Negative reciprocal slope. So if it was 2/3, it would be -3/2, right? And so forth. So that's the key stuff that you want to study on that, okay? All right, now I want to mention one thing on this, too. You could take this point, and this is a fairly good thing to do on here. You could take the point that I gave you was -8 and 1. So if you did a problem like this on a test and you wanted to find out if you're right, it's not hard to do. If you plug in the 8, you would have 8/3 times -8 plus 67/3, and then you would see if that's equal to 1. So you could just check it out and see, notice if you did this, that's going to be -64/3 plus 67/3. So that's equal to 3/3. Look at that, it's equal to 1. So what I'm saying is, on a problem like this, if you want to find out if you have the right answer, just take the point and plug it into your answer. If it works, you're right. Doesn't take that long to do. Wouldn't that be a decent thing to do? No response. Okay, I think it's decent. If you have an ability to tell you're right on something, that's something you ought to do, don't you think? Okay, all right. Okay. All right, piecewise function. A lot of times students do not do well on piecewise functions. So you'll definitely need to be able to graph a piecewise function of some sort. Probably the best way, in my mind, to learn how to do this is just make two tables of values. Okay, so basically that's what I'm going to do on this is just make two tables of values. So we're going to make a table of values for the first piece. Like that, and then we're going to plot it. So let's just over at the side, let's make a table of values. Okay, we got x, and we're looking at y equals x squared plus 1. Okay, first of all, what does x squared plus 1's graph look like? What kind of graph is that? It's a parabola. Okay, all right. Now, here's the key thing that you got to pay attention to. What kind of numbers do I need to use for x? What's it say? Got to be less than 2. But you still want to start at 2. That's what students don't do. That just means that it's going to be a bubble, okay, because that's just a less than. It's not less than or equal to. So you want to go ahead and use 2, but when you plot the point, use a bubble. Okay, now take points that are smaller than 2, like 1, 0, -1, -2, whatever you want, just enough to get a good graph, okay? So what we're going to do then is we're just going to plug in the x values and work out x squared plus 1. So we're going to work out 2 squared plus 1 to start with. Okay, so that's going to be 4 plus 1, or that's going to be 5. So that'll give a point on the graph that's going to be represented by an open bubble. Okay, then you're going to plug in 1 squared plus 1. That's 1 plus 1, so that's equal to 2. Now plug 0 in. So you have 0 squared plus 1 is 1, and then keep going with the rest of them because we need to get as many points as we can. And then if you go -1 squared plus 1, that's back to 2 again, okay? It's got some symmetry to it. And 1 plus 1's 2. Then the next one, if you go -2 squared plus 1, that's back to 5 like that, okay? So it's arithmetic, seriously, on this, okay? Make tables of values and you'll do well as long as you do your arithmetic okay, right? Now when we plot these points, as we're going through and plotting the points on these things now, what we want to do is be sure that you use the bubble for that one point that we put on there. Let me erase whatever that thing is. Okay, so let's put this in. So we're going to have the point 2, 5, and go over 2, up 5, and put a open bubble there. Stop that. Like that, okay? 1, 2, plot your point. 0, 1, plot your point. Negative 1, 2, and then negative 2, 5. Like that, and then do this. Now, I'll tell you something that students do all the time on this, is they want to make the parabola go past that bubble. Do not make that parabola go past that, okay? That's what the problem says, is it says you are graphing x squared plus 1 when x is less than 2. I always see students just keep going on and on to both directions. Stop at that point. Now what we're going to do is we're going to do another table of values for the second piece. So we're going to do a table of values for absolute value of x. Now, what kind of numbers do I need to use on this one? 2 and bigger. It says x greater than or equal to 2. All right, when I plug in 2, is that going to be a solid dot or an open one? It's going to be solid. That's what the meaning of that equal to bar means. Okay, what does absolute value look like? That's the v thing, right? That's helpful to know that. So now let's just take a couple of numbers bigger, like 3, 4, 5, or something like that. Okay, well, what we're doing is just absolute value of 2 is 2. You can do the rest of these in your head. Absolute value of 3 is 3, and so forth like that. So then you want to plot that second piece, and then you've got your piecewise function. Okay, so we got a point 2, 2 that's solid. Got a point 3, 3, 4, 4, 5, 5, and so forth like that. So then you want to go ahead and draw that, and you want to put an arrow at the end of it. Like that, that's your piecewise function, like that. Okay, got a gap. And the other thing I always tell students to do on this is, because I always see this problem, this thing should pass the vertical line test. Does this thing pass the vertical line test? Yeah, because every place you go is going to go through one point. So whatever you do, do not make that parabola go on forever. I see that from students constantly, regardless of what level of class I'm dealing with. It's 2 pieces, okay? All right, so study that. That's definitely something that I like students to be able to do in college algebra, is graph a piecewise function, okay? All right, any questions? Does that look good? Okay, 2 tables of values, that's key. Do arithmetic, plot your points correct. Okay, so let's see what we've got on the next page. Okay, so this is a transformation problem. So what I also do is some kind of a basic, the function can be anything, and it's got transformations. We're going to do a table of transformations on this now. What's that?
We did this one already.
Oh, okay, well, let's go through it again. I'm going to go ahead and do that, okay, because we need to. I know we did this in class, but I don't know if you remember or not. Okay, so let's go ahead and just do the absolute value. We're going to use these points. What I typically have you guys do is a sort of a chart here of transformations. This is so hard to draw lines on this thing. All right, so what we're doing is just the absolute value of the x value I give you. So that's going to be negative 2, 2. That's going to be 1. That's going to be 0. This is going to be 1, and so forth like that. Okay, so that gives basically the elementary points on this. Okay, now if you look at what we're plotting on this, we have the point 2, x plus 3 minus 4. All right, let's look at what all these things do. What does the 3 do? Without looking at the problem we already did. Left 3. Good. How do you know? It's inside of the function. It's inside absolute value. What does the minus 4 do? Not multiply. It's really subtracting from the y value, so it's taking you down 4. Okay? And what does the 2 do? Okay, and that's a good way to think of it, is you're multiplying y values by 2. Now, there's an order to this. The other thing you got to study on this is the first thing that you always do in your transformation is you always do left-right things. That's always the first thing. The last thing that you always do is you always do up-down things. Okay, and then the other things kind of are in the middle of the 2. So what we're going to do is we're going to make a column. We're going to, first of all, we're going to take everything to the left 3. Then we're going to do the second step, which is going to be multiply y by 2. Okay, then the last step on here is going to be, we're going to go down 4 like that. Okay, so what I do is you have to fill out this table of transformations. This is just something I require all the students to learn how to do. So if you're going through and doing this first step, what changes, x or y?
X.
X changes. If you're going to the left, it's x that changes. It's not the y value. So these y values that we've already established are going to stay the same. So it's just 2, 1, 0, 1, 2 like that. Okay, they stay the same. Okay, what changes? What changes basically is the x value. So you're going -2, left 3 would be where? -5. -1, left 3 is going to be where? -4. 0 goes where? -3. 1 minus 3 goes to -2. 2 minus 3 goes to -1. Okay, now we're not going to plot this thing until we do the very end. I'll show you that. Okay, so now we've got that taken care of. Now what we're going to do is we're going to multiply the y values by 2. Okay, that's what that number in front of the absolute value is instructing you to do. So you do that. So basically what's going to happen is all these x values are where they need to be. Okay, we're not doing anything else in this problem with the x values, so those things stay the same. Okay, now you can just do this in your head. Take the y value and multiply it by 2. So 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4 like that. Okay, so be sure you pay attention to the order we do these in. Okay, the last transformation we do is down 4. All right, so what changes? Y changes. What happens to x? Nothing. It stays the same. So good. Just keep bringing these things down like this. Okay, now you're just going to make all of the y's get smaller by 4. They go down 4, so you're doing really 4 minus 4 is 0. 2 minus 4 is -2. 0 minus 4 is -4. 2 minus 4 is -2. And then 4 minus 4 is 0. Like that. Okay? So, does everybody follow that okay? Okay, so that's just knowledge of transformations, how they work. Now, what I want to do on this, on the graph, is usually what I like you guys to do is to graph the original, which is the original points, and that's just going to be the V shape. So I'm going to plot the -2, 2, the -1, 1, the 0, 0, and so forth like that. That's called the elementary function. So I just plot that. Okay. Then what I want to do is we're going to graph out all of the final points. So now we graph out the final thing, and then you should be able to see that this looks right. So you're going to go plot the point -5, 0, -4, -2, -3, -4. I think I got that right. And then -2, -2, and -1, 0, like that. All right, so if you look at this, can you see that it's moved left 3 down 4? Yeah, can you see that it's stretched? That thing has been kind of pulled on in the y direction like that, so all those transformations are done. So basically, a lot of times on these problems, you'll be able to tell if you're getting this right, because if it doesn't look like that V has been moved that way and stretched, then you got to be wrong. Okay, so be careful about that. Okay, all right? Here's one other thing I want to mention on this too, is you can tell you're right on this. Okay, so you could basically pick any point that you wanted to. Like, for instance, you could pick, let's pick -2. Let's take like this point right here and plug it in. Plug it in and see what happens. So you would get g of -2 would be equal to 2 times -2 plus 3 minus 4. So that's 2 times 1 minus 4. And if you work that out, that's -2. So it's right. Okay? And you can do things like that on tests. This is one of the things a lot of times students don't do in math classes, is they don't learn it to that level where they can just start getting confidence that you're doing things right. So you can do that if you want to. Take those 5 points and check a few of them, and if they're right, then you're good. Okay? So that's something you ought to think about doing. Okay, let's see. Now let's go down and do the rest of these things. Another thing I like students to be able to do is if I give you a function, like something like f of x equals x to the third, I can give you any elementary function. We want to be able to build a function that has those transformations in it. Okay, so let's see if we can put this together then. Okay, if I want this to go to the right 2.5 units, where would you put the 2.5 in that function? Not after the x. It's anything that you do to change x has to be inside of the operation that we're doing. The operation's taking something to the third power. So what you're going to do is you're going to put that 2.5 in there like that. Now, if you're going to the right, what do you put there, plus or minus? Minus. Remember, plus is left, minus is right. That's how that goes, okay? Now, where do you put the 9.8 if I want you to go down 9.8? Outside the function, and since it's down, you're going to subtract like that. So it's all where these things are, see, okay? All right, and then one more thing. What if I wanted you to reflect it over the x-axis? What do? You put what? A minus where? There, like that. Okay, so it's just testing that you know where these numbers go and that kind of thing like that. So basically the idea on this is if you have something, a general thing like this, just as an example, if you had, say, negative 2, x plus 3 to the second plus 8. What does this do? That's left. So notice that the left-right thing is inside the parentheses. That's up 8, that's outside parentheses. Reflect is outside, and then that is a stretch by 2. So those are the things that you want to be sure that you understand. Okay? Right? Okay, so that's another thing that I'd like you to be able to do is build a function like that. Okay, let's see. Let's look at just graphing. Okay, so another thing is just graphing a line, so I'd expect you to be able to do that and everything. So generally students do this okay, as long as they got a good background. So if I want you to graph this line, what you want to do is solve for y first. So we're going to just move the x to this side, so we'll get negative 2y equals 4x minus 8, like that. Then we can divide both sides by negative 2 to finish solving that for y. So that's going to give y equals, and then this is going to be negative 2x, and then the two negatives here become positive 4 like that. Okay, so you're going to do that. All right, so what is the slope of this line? Negative 2. Okay, that is your slope, like we've learned. Okay, so that's negative 2. What's the y-intercept? That's your y-intercept is that number right there. So you write that as the point 0, 4, like that. Okay? So once you solve for y, you can find the slope and y-intercept. So okay, so if you're going to graph this, first thing you're going to do is you're going to put a dot on the y-axis. Okay, so that's dot number 1. It only takes 2 dots to make a line anyway. So we put a dot there. Now if we have a slope of negative 2, you want to put that over 1. So it's a rise over run. So how do you count the negative 2? Up or down? Down. Okay? The bottom number is left or right. What are you going to do? Right, because it's positive. Because you're going to go like that. Okay, so what you're going to do is from this point, you're going to go down 2 units, and then to the right, and then you connect the dots. You can do it again if you want to, but you're not required to do that. Okay, so down 2, right 1, like that, down 2, right 1, and then you can connect that into a straight line like that. Okay, there is a way to tell that you're right on this problem too. I know students a lot of times don't like me going over this checking stuff. I don't care. The thing is, it's how you understand math better. See, that's a 0.12. If you want to find out if your answer is right, here's what you do. You take a point on the line and you plug it in. And if it works, guess what? You're right. Okay, so what you have is negative 4 times 1 minus 2 times 2 is negative 4 minus 4. Hey, that's equal to negative 8. Look at that. We just verified that one of the points on our line is right. So guess what? The graph's right. Okay? All right? Math has that capability. As you can tell, you're correct on almost everything you do in an algebra class. Okay? So do it if you choose to. Okay, any question with that? Okay, so you definitely want to be able to do graphs of a line. And then let's take a look at algebra of functions, and then one other thing, then I think we'll be finished up here. So, all right, so if we're doing this.
You skipped 26.
Oh, I skipped 26, sorry. That's because I couldn't see it. There we go, okay. All right, so let's look at intercepts, okay. So in general, what you want to do, anytime that you find an x-intercept, what you want to do is you want to set y equal to 0. And then anytime you find a y-intercept, what you want to do is you want to set x equal to 0, like that, okay? So it's just the opposite variable. So let's find the x-intercept. So you go here, replace y with 0, so we're going to have 0 equals x squared plus 16x plus 63, okay? How do you solve this equation? You factor. Yeah, you got to be able to factor. There's going to be a couple of places in the test where you're going to need to be able to factor trinomials. Okay, so that's x and x there. What are the numbers that multiply to give 63 that add up to 16? 9 and 7, right. Okay, you got to think about that a few minutes sometime. So it's going to be plus 7 plus 9. You know, FOIL it out to make sure you're right. So then what you have is x plus 7 is 0. So that would give x equals negative 7. So that's one of your x-intercepts. And then the same thing with this, you're doing x plus 9 equals 0, so that gives x equals negative 9 is your second intercept, like that. So this problem basically has two x-intercepts. So you're going to have negative 7, 0 is your first one, so you write that like that. And the second one is negative 9, 0, like that. Okay, so everything's put together then. Okay, all right. Y-intercept, what you're going to do is go to the function I gave you, and everywhere you see an x, you're going to replace the x's with 0. So that's going to be y equals 0 squared plus 16 times 0 plus 63. So that's going to be 63. So you write that as 0, 63. Okay. And notice on this too, like if it's an x-intercept, y is 0. If it's a y-intercept, x is 0. And so you're going to write the points like that. Okay. Okay. So that's kind of a thing where I can give you any equation that I want to, as long as you have the ability to solve the equation okay, then you can get that correct, okay? All right, does that look okay? Okay, opposite variable goes to 0. That's the key thing you want to remember, okay? All right, now we can go to 27, I think, okay? All right, algebra of functions would be the next thing. Okay, so if you're doing f plus g of negative 4, what you're really doing, one of the best ways to do this is we learned that that's the same thing as f of negative 4 plus g of negative 4. So we just need to figure out what f of negative 4 and g of negative 4 is, then add them together. Okay, so I'm just going to do this at the side of the paper over here. So I have f of negative 4 means that we need to go to the function that's called f and replace that x with negative 4. Okay, so that's going to be square root of 1 minus 2 times negative 4. So that's going to be square root of 1 plus 8. So that's square root of 9. So that's going to be equal to 3. Okay. So that we're going to go back and replace this now with 3. Again, I try to make this on a test without a calculator. Things that are pretty straightforward. Nothing really major. Okay. Now we're going to do g of negative 4. So that's going to mean that we go to the other function, and where you see an x, you want to put in negative 4. Okay, so that's going to be 2 times negative 4 to the second minus 10. So that's 2 times 16 minus 10. So that's 32 minus 10. So that is 22. Okay, like that. Okay, so the answer to this problem is 25. That's arithmetic. Now, these two problems on this on number 27, they're arithmetic problems. Part of that is learning the language of functions, like that. Take the two functions, values, and add them together. Okay, next one, what you're going to do is we learned that f over g of 0 just means that you do f of 0 over g of 0. Okay, so you just work those two things out separately. Okay, so if you want to do f of 0, you're going to plug the 0 into the square root function. So that's going to be 1 minus 2 times 0. So we're going to do that. And then you plug the 0 in there to find the g of 0. So g of 0 is going to be 2 times 0 squared minus 10 like that, and then work out the details. Okay, right? So when I get that plugged in, it looks like f of 0 is going to be square root of 1. G of 0 is going to be 2 times 0 minus 10. So that's 1 over 0 minus 10. So that means the answer is 1 over negative 10. So I'm just going to write that as negative 1/10. Okay? Those two problems are arithmetic problems. Okay? Just do what the arithmetic of the functions. That's the idea. Okay? Okay, does that look good? Okay, all right. So we've done some composition of functions, then you're going to do some algebra of functions. I think there's one more problem, right? What's that? That's it? Okay, my goodness. Okay, all right. Okay, so these are the things that, these are the main things you want to get through and study. I think that one thing that you want to do is, maybe go through the longer test review and just kind of pick some more problems out and work it. But these are the big areas for college algebra in chapter 1 and 2. So be prepared to do these. I always say when you study for something like this, just take this test, randomly pick a problem, work it out without looking at any notes, because you're not going to be able to look at notes. So be sure that you do that and just see if you're on the right track. Okay, so things are going to be fairly similar, no great surprises. So similar ideas, okay? All right? Any questions? Okay, yeah.
The last question, negative 1 over, the radical of 1 over negative 10, how does that change to just 1 over?
Well, okay, the numerator there, when I plugged it in, I'm doing 1 minus 0, really, right? Okay, because 2 times 0 is 0. 1 minus 0 is 1. Then the square root of 1 becomes 1. That's how that came. Okay, it's arithmetic. What I'm doing is I'm kind of working underneath the radical. I'm following order of operations. You multiply before you subtract, right? Okay, that's all arithmetic is what you're doing there, okay? All right, guys, so you got two choices. I'll let you go early, or I'll let you work a little bit on your MyMathLab homework, or if you got any questions, hang around here and help you out a little bit, okay? Then I'll post this, so if you want to look at these things before the test, you certainly can do that if you want to.